Hello, everybody. Welcome to today's Dynamics 365 Tech Talk. Today's topic is Export to Azure Data Lake Scenarios and Architecture Patterns. My name is Brad, and I'll be your moderator today. We are broadcasting this session through Teams live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to this experience. The recording will be available on the Tech Talks Community Dynamics page within 5 business days. If you have questions for the presenters or need support, please use the Q&A panel located on the right side of your screen. Our presenters will be responding to your questions throughout the event and during the Q&A segment near the end. Thank you for your patience during these announcements. Kicking things off for us today from Microsoft, we have Rich Black, Senior Program Manager. Rich, over to you.
Apologies, we've got an issue with the audio here, Brad.
And just a moment for our attendees out there.
Okay.
Slight technical difficulties.
Hold on, let me reshare that.
And JJ, we cannot see the video currently.
Yeah, I'm sharing it back.
And just another brief moment here, folks. We will be underway very shortly.
The Lake feature, and in this Tech Talk, we're focusing on scenarios and architecture patterns. First, let's take a look at our agenda. In today's Tech Talk, we'll start with a quick recap in case you are new to the topic. We'll quickly cover the current status of the feature as of today and the product roadmap for the near future. Then we'll discuss some of the basics of data modeling, and then we'll spend most of the hour reviewing various scenarios and applicable architecture patterns with several demonstrations. Finally, we'll talk about what's next. This Tech Talk recording and the deck will be posted to the Microsoft Dynamics 365 Fast Track Tech Talks page on the community.dynamics.com website. As mentioned, this is the second Tech Talk on Azure Data Lake. If you haven't yet seen the first, navigate to the community.dynamics.com website and check out the recording on demand. In that first Tech Talk, we provided an overview of the feature, demonstrated the setup and the configuration, explored data using Synapse workspaces, provided tips on how to query, transform, and visualize data in the lake, and discussed some basic patterns and anti-patterns to be aware of during implementation. Today, we'll pick up where we left off in that previous Tech Talk. Export to Azure Data Lake is a managed, scalable, and highly available service that lets you select data for export from finance and operations to an Azure storage account in the same region. You can select data by using either tables or entities, either standard or custom, and the export is managed by Microsoft using a microservice that does not impact your production operations. This capability is generally available now and provides a periodic full export of the selected data. Near real-time updates is a preview feature that you can enable today in non-production environments. When you select this preview feature, data is inserted, updated, and deleted in your data lake in near real time. In addition, you can update downstream data warehouses by using changed data in the data lake, also known as the change feed. By using this change data folder, you can easily identify the changes that were made to data, and you can create near real-time data pipelines. Enhanced metadata is another preview feature. When you install the Export to Azure Data Lake feature and select data to add to the lake, the system writes metadata files in addition to data. Selecting the Enhanced Metadata Preview option when you install the add-in enriches the metadata that is written to the data lake about the data you select for export. Business Events is a framework in Dynamics 365 and Dataverse that lets you easily create intelligent actions and automations. By enabling this preview feature, you can be alerted when something important happens in the data lake. For example, data is initialized. The system generates a business event when the initial copy of data is completed. Coming soon, we also have improvements planned to the UI and to the Synapse Link experience to better align F&O and CE capabilities. And finally, some fields, including some potentially large memo or XML fields, are excluded from export right now. We have plans to enable you to optionally select some of these additional fields for export. Next, let's talk briefly about data modeling and data platform basics. This will clarify why we're using Data Lake and where the technology is heading, and this will set the stage for our exploration later of various architecture patterns. JJ, over to you.
To build any efficient analytical and reporting solution, building a proper analytical data model is critical. And it's fundamental for building a successful reporting and BI solution. So let's first understand why this is important. First, many times the ERP system is not where all the customer data is stored. There could be multiple sources of the data that are often needs to be brought together for reporting. From finance and operational standpoint, you may have data from your legacy ERP system or customer engagement applications or any other applications. You may have to bring those data together to build efficient end-to-end reporting solution. The second point is the data that comes out of the LOB applications are not suitable for reporting. It can be due to data quality issues or the fact that data model is so complex to understand or build direct report on it. ERP systems are designed for write intensive workload, and data model is highly normalized and optimized for write efficiency. BI analytical workload is read intensive operation. You need to denormalize and make the data press in more business friendly so that reports can be built on it. So solution to this problem is we have always been doing ETL process to bring all these data sources together to solve disperse data problem, and then doing the transformation, data cleaning and denormalizes or transformations of the data to bring to a proper analytical data model. So result of this would be a analytical data model, which we often refer as a star schema, where you have a fact tables, which basically is going to provide you the details of all the calculations. And then you have the dimension tables, which are going to be used for filtrations and drill down of the reports. As an example, on the left side, you have the finance and operations data model for financial data. Building any report directly on this is going to be complex. It is logical to do transformations and convert this into a star schema model, as you see on the right side of the picture, before doing reporting, so that the business user can understand the table names, field names, and relationship much more easily, and it's easier to build reports and BI solutions. Let us look at the evolution of the data platform with the data lake. Starting from the left box, traditionally, all our data that we needed for BI and reporting were coming from structured data sources. Data was stored in relational databases, and we were using ETL pipeline to merge, transform data to data marts or data warehouse.
and build reporting solutions on top of it. Now, in the middle box, the data is coming from everywhere, structured, semi-structured, and unstructured sources. And also the size of the data has grown, and hence the cost of storing and processing data using relational databases has increased. You need cheaper storage for data and faster compute to process large amount of data. Cloud data warehouse solutions are built with that compute and storage separation so that you can independently scale the storage and compute to process large amount of data quickly. Several cloud-native ETL or data processing tools are available that can connect to various data sources to bring the data to the lake or do data transformation. You can use low-code platform to run ETL or use pro-code tools such as Apache Spark to run the data transformations. You also have data virtualization solutions that provide ability to query and transform the data using T-SQLs while data is still stored in the lake. You can build a logical data warehouse and join and transform your data without moving the data. On the right-hand side, data lakehouse architecture is providing data warehouse capabilities within the lake with metadata, data virtualizations, and governance layer. In the lakehouse architectures, raw data is stored in the lake in the native format without any transformation. And then using data processing tools, it cleans the data and define and store the data in the lake. And finally, curated data is produced to represent an analytical data model. While raw data can be used for exploration, refined data can be used for data science and machine learning, and curated data can be used for BI and reporting. A customer that is using Azure Data Platform to build reporting and BI solution, let's see what tools and technologies available in this space to build modern data warehouse architecture. So first layer is data lake or ADLS. Azure Data Lake Storage provides low cost and high performance storage layer to store all your data. Dynamics 365 data is already exporting in the data lake. If you need to bring your data from other sources, such as cloud apps streaming on-prem data, you'll use Azure Pipeline or Stream Analytics to bring the data to the data lake. For low-code data preparations, or ETL transformations, you can use Synapse Pipeline or ADF again, or if you're code friendly, you have resources who works on the Spark and big data technologies, you can use Apache Spark pools to do the transformation. For data warehousing workload, you have a Synapse dedicated pool, which is multi-parallel architectures and provide petabyte scale data warehousing capabilities. For data virtualization, you have Synapse SQL Serverless, which can be, directly read the data from the data lake and provide query engine to do T-SQL queries on the data which is in the lake. And all these components, Synapse Pipeline, ADLS, Apache Spark, Serverless, dedicated pool, all integrated within a single workspace, Synapse Analytics. And in addition to this, it's providing security, monitoring, source control, and all the governance layers on top of it. With that basic background, let us discuss various architecture patterns that you can build with your Dynamics data in Data Lake using Azure Data Platforms. We'll describe architecture patterns. We'll also do quick demo for each. Demos are intentionally kept short. We have solution templates and detailed demo videos in the GitHub that you can use to build your end-to-end POC. So with that, let me hand over to Antoine, who will talk about the first architecture pattern.
Thank you, JJ. Let's start on some of the architecture patterns with respect to Dynamics D365 data. This pattern uses fundamentally the serverless SQL to Lake database concept to virtualize the data in the lake and build logical data warehouse structure without moving the data out from the lake. In this pattern, the Dynamics D365 applications are moving the data in the lake, and then you use the serverless or lake database concept in Synapse to create the logical data model and then import the transformed data in Power BI. Here are the steps required to achieve this architecture. First, we will use the CDM util to create serverless external tables and views. Next, we will create data entities as views. This is an optional step and will allow us to have denormalized data. After this, we will create the star schema logical data model. Once we have the data model, we will create our Power BI dataset in import mode and build our report. And we can set up the Power BI data refresh incremental or full as needed. Now let's go and create our first report of our logical data warehouse using serverless pool. So for the purpose, we need one Dynamics environment, which has been pre-configured with data lake extracts. And here is the environment which I'm going to use. Here I have the list of tables. It is important to note you can extract the data from the environment using tables or using entities. So when the entities are selected for extract, you can see the tables on the right side. So these tables will get scheduled for extracting as well. And the entity definition as a view will get extracted to our storage account. This is a fundamental for building our data model later on. Now, let's take a look how this storage account looks like and how does the data inside is scheduled. And this is the account, and the data inside is contained into our containers. It's organized into two different sections. One is the physical data, the other one is the views definition. So the physical data is contained into the tables and the change feed, and our view definitions is contained into the entities. Now, how does the data, when it lands into here, gets into our serverless pool? For the purpose, we are using a utility called CDM util, and this automatically converts the data from the inbound manifest files in definitions into our serverless pool. Now, this is utility which you can get from our GitHub account, and you can deploy the utility in two different ways. One is via console application, which will execute locally, and the other one is via Azure function. Now, this is the deployment type which we're going to use for our example, and this Azure function has been already deployed, and what we need to do is to connect the execution of this deployment to event which happens with our storage account. Now, what this event will do is every time when there is a blob changed into our storage account, it will fire this Azure function. Now, to make it to work only on our definitions and not to work on any of the data files which arrive, we'll put some filters. And it will specify to collect only data from this specific directory and only for objects which end with cdm.json. And you can add more specific filters if necessary. Now, this will ensure that once when blob has been created or changed, it updates automatically the view definitions in our SQL serverless pool. Now, I'm going to go to our Azure Synapse Analytics workspace, and this is the serverless SQL endpoint which we're going to use. I'm going to open this serverless SQL endpoint using my SQL Server Management Studio. I have a couple of databases which have been defined in there. This is the one which connects with my data storage account. The CDM utility is looking over this database, and it is creating the views inside as external tables or views, which are representing the data entities. The next step, which is to create our data model. And our data model will contain a combination between entities or physical tables, or indeed both of them, or new views created as part of the data model. So what we have is different schemas, which I have defined so I can easily distinguish my data model. And I have built a script to generate my data model manually. Now, once when we have this model set and operational, we can go the next step, which is to build our Power BI report. Now, I have here one Power BI report, which I have pre-built and connected to this data source already. Let's take a look on one of the tables inside in this Power BI dataset. And I'm going to open the edit query. And in here, I'm going to open the advanced editor. As you can see, it is connected to our serverless SQL endpoint, and it is picking up the item, which is our view general journal transactions. Now, when this is in place and it is preset, we'll start receiving the data into the format which we see on the screen. So when you have this one completed, your data model is going to look ready and visualization is going to look something like this. Of course, you can build any layers of visualization or any different complexity. Now, because of the established relations, we can select the data and do some filtering. And as you can see, the data is selected and filtered quite rapidly. Now, this is because we have selected a specific type of data set. Now, when you start working with Power BI, you can open a data set which is of a type import or type direct query. So for the purpose, let me quickly open one additional Power BI desktop. And here I'm going to get data from a SQL data source. Now, the data connectivity mode is either import or direct query. The import will result the data set being importing the data from the source and storing it and serving it with increased speed. The direct query will result in any kind of data request being sent directly to the data source and executed at the time. Now, in case of a serverless, we are going to have a lot of queries firing up to the serverless pool, so you need to think about performance of the pool and costing model. So the import option will give you performance advantage, and you can schedule these imports to be on a regular basis or timing intervals. And with this, we completed our first report.
Now let's look at an architecture pattern consisting of a cloud-based data warehouse using a dedicated SQL pool. As in the prior demo, the intent is to use data exported to Azure Data Lake to generate a Power BI report based on a denormalized general ledger view fact table. In this demo, we'll divert from the serverless data virtualization pattern reviewed in the previous demo, and this time we're going to use a dedicated SQL pool to host our data model, and we'll transform our data using Synapse pipelines. First, given our data is already exported to Azure Data Lake, we'll use the CDM Util console app to create some tables in our dedicated pool. Second, we'll also create a handful of views that are the basis of our finance data model to get us started. Third, we'll use a Synapse pipeline to move data from the lake to our newly created tables in our dedicated pool. Fourth, we'll define our star schema data model and use another Synapse pipeline to convert or materialize our views to flattened tabular data in our dedicated pool. And finally, we'll import the dataset into our Power BI report. In this process, data exported from F&O, represented by the data model at left, will be moved into tables in our dedicated pool and transformed into the denormalized data model at right. Note that I've created a dedicated pool in Azure and I've connected to it using SQL Server Management Studio. It's freshly created. There's no tables, no views, no data or anything at this point. CDM Util will be used to create the tables in our pool. CDM Util is located here at GitHub. It's a fast track utility. What we're demonstrating now is one of the common use cases that we have documented here. I'm going to go ahead and run the CDM Util console app now. CDM Util is going to loop through. Right now it's reading the manifest of all of the JSON files out there. Here we can see that it is creating those tables right now successfully. And if we were to go look at SQL Server Management Studio, we would see that now we have empty tables. While I'm here in SQL Server Management Studio, I am going to go ahead and create a handful of views. Again, CDM Util has the option of creating views for us based on entities, but we're going to create these that we're interested in right now. We're going to go ahead and create these manually. So now I have tables and I have views in my dedicated pool. Now we're going to run the Synapse pipeline to copy data from the lake into those newly created tables in our dedicated pool. Copy Synapse table is the Synapse pipeline that we're going to use, and this pipeline is provided in GitHub as a template. We'll run this pipeline, which will loop through that same list of tables. Here is that list, and we can refresh this pane here to view the status. And Given the dedicated pool that we're working with the smallest SKU available, and the record set that we're working with, it'll take about a minute to go ahead and copy all of the data from those source tables into our dedicated pool target tables. And if we head out to SQL Server Management Studio, we can confirm that we do indeed have some data out here, and we can see that we've got about 4 million records in our general journal account entry table. And that has finished populating at this point. Yes, indeed. Now we have our data in our tables. However, at this point, the views are just views, and they're not materialized or populated like an entity export, and they're not flattened into the finance data model that we ideally want. So now I'm going to transform that data and materialize my views, and I'm also going to flatten the structure into that simplified data model shown earlier, optimized for my data set. Here's that Synapse pipeline. Here's the script, and you can see that all we're doing with this script, this is a relatively simple example, but we're basically combining all of these tables into a flattened general journal transactions table. We'll go ahead and execute this pipeline using debug, refresh to check the status. And this one again will take about a minute to complete the process of moving data from our source tables in the dedicated pool into our new data structure. And once that process completes, then we'll be able to open up our Power BI report and import all of the data. And we'll be running that report in import mode, and our report will have the full data set loaded. At that point, we can actually go ahead and turn off our dedicated pool if we like. We'll go ahead and refresh the data in our Power BI report. And once these rows have imported into the report, that'll conclude our demonstration.
Let's talk about the architecture patterns Lakehouse using serverless pool. Idea of this architecture is implementing similar data structures and data management features to those in the data warehouse solutions or relational databases, but storage of the data is always the low-cost storage used for data lake. So there are a few key technologies advancement which has enabled this Lakehouse architecture. The first is the metadata layer for data lakes. So not only the data, but metadata has to exist in the lake. The second is the data format that provide ACID or atomicity, consistency, isolation, or durability properties in the data lake, similar to relational databases. The third is you need a query engine, which is designed for providing high performance SQL execution on the data lake. Delta Lake is open source data format developed by Databricks, is leading data formats used in the Lakehouse architecture. If you look at the three technology advancement, which we talked about, the metadata layer and data format, Delta Lake provide those capabilities. So metadata layer, the Delta Lake stores the data and metadata in the Parquet format. It also provide additional metadata called as Delta Log, which provide the ACID properties in the data lake. Let's talk about some of the fundamentals of these different layers of the data lake in the Lakehouse architecture. Bronze layer is essentially the raw data from the source system that is available in the lake without transforming or cleaning. From finance and operation perspective, export data lake is exporting tables data in the lake, and this can be your raw zone. If you have other systems, you can use Synapse pipeline to bring the data in the raw zone, and you can use serverless, creating external tables or views and query and analyze that data. The next zone is silver zone or refined data zone. This is a zone where data in more refined format, like Delta Lake format. In this, you'll use ETL processing to create this bronze data in a silver format. You will be doing some data cleansing, denormalization, and data partitioning when you store the data in the silver zone. And the third and final zone is the gold or curated. Finally, create your data models optimal for reporting and BI, the star schema model. So you'll be producing the curated zone with the refined data. If you have multiple sources, you will be also combining those data points and creating your will be used Power BI reporting either through direct query or import mode. Silver can be used for machine learning and data science, as well as some exploratory testing. One thing I want to call out is when you do this data enrichment or data transformations between bronze to silver to gold, there are many options which you can use. You can use the Synapse pipeline data flow components, which is low code solutions, or you can use Databricks. The serverless in this case is more for a query engine, which supports Delta Lake format. So you can query using the serverless, the silver and gold layer, and that's how you will do the reporting and analysis. To enable this architecture patterns, you'll need export to data lake and enhanced metadata features. You'll need CDM util to create the bronze, and then use the Synapse pipeline to convert this data into silver and gold, and then use serverless to query this data. In this demo, we are going to talk about the Lakehouse architecture using Synapse pipeline and serverless SQL pool. To start this, in my data lake, I have finance and operations default folder. I also created silver and gold container. These are the new container I created. Finance and operation container connected to my export to data lake features, and the tables and change feed data is linking into the data lake already. On the serverless side, I created a bronze database, curated database, and silver database. Bronze database is connected to my export to data lake and CDM function app. So it's already created external tables for all the change feed folders as well as the table folder. So this becomes my bronze layer to do the analysis of the data and understand the data from the raw layer. So if I need to query this data using the T-SQLs, I can use serverless to query the data directly from the table folders as well as the change field. The next is I need to process this data from bronze to silver. So the first transformations which I'm going to do in this is silver transformations, which is a simple pipeline here where from metadata perspective, we are expecting a list of the table and metadata properties. And then this pipeline will go and run for each tables and then all data flow to do the data convergence and also create a view on the silver database on the serverless side. What it's doing is using the CDM as a source. It's using the common data model inline connector to read the data from the source CSV file, and then going through some small transformations here, and then ultimately sync the data in the target container, which is in this case is silver container, and it will follow the same path as the finance and operation folder structure. For the gold transformations, what I have is different pipeline. One is doing the dimensions transformations, and second one is doing fact transformations. So if you look at the dimension transformations is reading from the Delta Lake folder. So once data tables are produced, this transformation is reading from the Delta folder. And here you can see the reading from the finance and operations silver containers, and then the folder path, and then doing some transformation and syncing back data to gold container. If you look at our fact transformation, there are multiple tables being joined into this, and there are some additional transformations where we are selecting the columns, the final columns, what comes out in the gold, as well as creating some derived columns. And we'll be using the partition scheme in the Delta Lake, Delta Sync to partition the data in accounting year, accounting month, and accounting day format. I have run this pipeline, so you can see these pipelines are executed here, and it didn't take much time. So if I go here in the containers, silver and gold containers, the result of this is the data is written here in the Parquet format, and Delta Lake log is also present. If I go back to the gold container and look at our data here, so if we look at the general transactions, and we also use the date partitioning scheme, so it partition the data in year, month, and date format. So I can use that for partition eliminations and to speed up the queries, which I'm going to use. So on the Synapse SQL Serverless side, you will see that you will have on the curated side as well as on the silver side, you'll have the views created for these transformations. So you see here in the curated model, I have the views created for business unit, cost center, department, all the facts and dimensions which I processed.
On the GL things, you also notice that accounting year, accounting month, and accounting date are all available here as well as a column when I do the delta processing. So you'll notice that like this is a tables which is created as a delta. So here, if you look at the script of this, is just using the format as delta. And I can use the partition eliminations using these date. So the next step on this is connecting to the Power BI report. So I have the same Power BI reports which we started our demo on. So this Power report is now connected to the curated data lake. And you can see that if I go here and look at the source properties of this, so it's basically connected to the curated database and pulling the data from there. You can use this direct query or as a import mode in the Power BI.
Thank you. We also have this demo recorded and solution available in the GitHub, so you can try a detailed version of the demo and solutions as well.
Hi all, I'm Aman Nan, and I will show you another approach to building a lakehouse architecture utilizing Delta Lakes. I will build an end-to-end data ingestion pipeline in Azure Databricks along with some near real-time dashboards. Since I'm using Databricks, this example is more programmer friendly as the entire pipeline is in Python. The use case here I'm taking is of a commerce company that has an e-commerce website as well as traditional retail stores. They want to analyze online clickstream data to better understand their customers. We will use Dynamics products and customers data in the data lake to do some lookups and joins to enrich this raw data or bronze data. And we will create few refined silver tables and then do some aggregations and create gold tables, all within one Databricks instance. If you see the screen here, this is basically the architecture. It's a Lambda architecture. We are combining real-time data, streaming data coming from Event Hub or IoT Hub, as well as batch data or historical data coming from business applications like Dynamics, and all sitting in Data Lake. So let's jump into the code. I'll keep it high level and show overall steps. I will also record a more detailed video and provide that in GitHub. So this is a Databricks instance. It's all provisioned within Azure. We are utilizing a few other Azure technologies that I will show you as we walk through this code. Since it's clickstream, I had to generate some clickstream data. So I am running a Python file in Visual Studio Code. It is sending this data in JSON format to event hubs, and the data is in the form of JSON with a customer ID, an item ID, device, and an event like add to cart, checkout, login, etc. So all this data is going to event hubs. So first of all, we need to mount the data lake storage, the folders, the containers that you want to access data from. In our case, finance and operations is one, and I'm also building a few other folders like commerce data to store this clickstream data. And then you provide client ID, tenant ID, secrets, etc. And then, as I said, we are looking at Dynamics customers table and eCommerce product tables. In this case, I'm reading customers in the data lake and calling in Databricks, filling up a data frame, and then having that data available in the form of. Likewise, we'll do this for products. And if I quickly show you, this is the file. It's sitting in data lake that you will export from Dynamics. So you'll create some data frames, you'll create some views, and you will create some JSON schema to read the different columns, some helper functions. Since we are ingesting from Event Hub, some configurations. In my case, I have Kafka enabled Event Hub, the endpoint. You write the code to read from Kafka, to read from CSV files, and it's polling real time within a few seconds. And then you create some bronze delta tables. You can call SQL code directly within the same file, and then create some data frames. So this was bronze table. Likewise, we'll create a silver table. We'll do some joins with our views for customers and products, and we'll add some more columns like product names or customer names. We'll do some transformation, take out the year, month, and day, and build some better looking silver table. So if I just go to the view, it has many more columns now. And likewise, you'll do gold table with some more aggregations, group bys, and quickly moving on. Now we will write this silver table from Databricks back to Synapse as well. So you make a connection to a data lake where Synapse is pointing, and then you call another function to read this data and in a data frame, and then write it to a Synapse table. If I go to the Synapse, you can see it's a Synapse dedicated pool, and the data is written in this table, and it's the same data. And if I have to show you how Databricks stores this, so if you go to the Databricks instance, you can see it also has these tables storing the same data. And the data is stored again in data lake. I have to go to the data lake folder. You can see bronze, silver, and gold tables. So that was writing to the tables. And finally, within Databricks, you can also do these analytics. You can create these dashboards, pie charts to do some quick analytics. And then you can take the same to Power BI with Databricks connectors as well. And I did not show in this example, but also you can do machine learning. You can write some product recommendations code. Machine learning libraries are available. So as you see with the Databricks pipelines, you get many more options all within one interface. And you can do some exploratory analysis and also build AI use cases. Thank you.
Thanks, Antoine, Rich, and JJ for showcasing various architecture patterns where you can modernize your BI and analytics solution using modern technologies. That's for long-term and for future. So most likely, your business will be having a reporting or analytics solution already in place. And for the short term, all you are looking is to bring data from FNO via Lake to your existing database or Cube for the least disruption. With this, you don't need to change your reporting, your Power BI report, or any other reporting solution. In your current solution, you may have existing database, which might be on-prem, or it could be on cloud, or you're using data warehouse, or maybe any other third-party tool or service where you would like to just ingest your FNO data right now. Totally different what it could be like you could be using for outbound data integrations, where you don't need data real time, but expect quick millisecond response time. Now let's understand this diagram. Just like before, we are leveraging the 365 export to data lake feature to bring FNO database to the Azure Data Lake. After that, we have two sub-patterns or two sub-architecture patterns here to accomplish the objective. One, we can use a Synapse serverless pool. As you saw in the first demo by Antoine, you can use the external table or views to virtualize the data in the lake. And once you use that, you can enhance that same solution using ETL tools such as Synapse or ADF pipeline to copy the data from Synapse serverless pools to your destination places. Those destinations, as we discussed earlier, it could be existing SQL, existing Cube, or existing any other third-party service, reporting service you are using. Benefit with this option is that SQL Synapse serverless pool simplifies schema detection and is easier to implement due to familiarity with T-SQL syntax you are using. Anyone capable of establishing connection to SQL can use this solution. Therefore, it enables many choices to do ETL using ADF, Synapse pipeline, SSIS, or maybe any other tool that supports SQL. The another option is directly reading the data from Lake and pushing that data to your destinations. Using ETL tools such as Synapse or ADF pipeline to directly read data from the Lake. And what you're doing is copying the data to the destination database or data warehouse. If you're planning to use Azure Spark or Azure Databricks, then this might be a better option, as these tools support loading or reading data from your data lake. If it does not support the CDN, you must use custom metadata detection logic and schema drift support. This option can be cost-effective compared to first option. However, the choice of ETL tool and compute will be limited. Once you have data in your preferred destination, then you can leverage your existing integrations, reports, analytics, or any of visualization you are built on already on top of it. Okay, let's have a demo of both patterns. One via Synapse Serverless Pool, where we will leverage the power of common data model utility, which provides a structured schema to our data in the lake. And second, we will create a pipeline directly sourcing data from the lake and copying the data to Azure SQL database as destination. So let's cover the first scenario where we will copy the data from lake directly to a SQL database. Our source is Azure Data Lake and our destination is an Azure SQL database. Here I'm showing the source. This is a storage account, which is getting the data from FNO directly via the export to data lake add-in. Let's see the customer group as an example. Under tables, you will have the whole structure. Under finance, AR, and you can find the customer table over here. For demo, we have added lots of data into the customer group table, and it's around 53 MB files, and it's around 500,000 records over here. On the destination side, we have the destination database, and there is no table over here right now. Customer table is not there. Now let's look at how we are achieving it. We have created an ADF pipeline, and these are the parameters where we are specifying the table names. The incremental false is it's running for full exports. These parameters are used when you do the incremental as true. These are the destination servers in database. We are providing the source lake name basically, and the URL and the path. And what we are doing high level is, let's take a look. We are checking for the new file. This happens in full export where it's reading the metadata and creating the table ultimately. How it does is it uses the CDM util function we have, and then ultimately it creates the table in the SQL database destination DB. Once we have created the table, what it does, it goes for other activity, which is basically copying the data. For this one, we use data flow CDM to SQL. What it does is it reads the data in CDM format using these parameters, and then it does some transformations, and then it ultimately syncs the data to the database, which is destination database. Let's run it and see how it looks. Okay, I will trigger the pipeline. I'll trigger now, not scheduling it, and I'm just doing it in full mode. It will start running immediately. See the pipeline run. All right, the run is succeeded. It has completed all the activities. Now let's check the database, our destination DB. It has created the table. And let's see how many records it got. It has created all around 500,000 records in the customer table in my destination DB. Now let me run again in the incremental mode. View the pipeline run. This time what it will do, it will use the change feeds folder, and it will start looking at the change data from the customer table files. And once the run finishes, you can see how many records it processed through the data flow pipeline run. You can see it has written 6 records. All right, we completed the demo for the first sub-pattern where we copied the data from data lake to Azure SQL database directly without using Synapse Serverless. Another option we have is Synapse Serverless, which is we have 2 pipelines, full and incremental. By the way, the whole solution is also available on GitHub under Synapse to SQL ADF, and it's documented. It has all the templates and everything available for you. So this concludes the demo of all the patterns. Now handing back to JJ for the comparison.
Now that we have learned different architecture patterns, let us compare these patterns in terms of compute, skill set, process, pros and cons, and use cases and recommendations. The first in the list is logical data warehouse using Synapse SQL Pool Serverless. In this, you will use T-SQL as your primary skill set. You will create the external tables views to read the data from the lake and then transform using T-SQL queries and view, and then use Power BI import mode for reporting. The highlight of this is you get near real-time data. You're not duplicating data, and you are utilizing your T-SQL skill set. The low lights on this is it may not be very optimal when you are doing complex transformations and join. So watch out for performance improvement, which you can do with the T-SQL queries on the server. And you also may have limited transformation ability with purely T-SQL scripts, which are supported on the serverless side. So consider those limitations as well. Use cases for that is you can build dashboard analytical reporting using the Power BI import mode, or you can also do some light operational reporting. The recommendation for this is if you have a medium data volume and workload and less transformations, you can plan this architecture and optimize for performance and cost control. When you're using cloud data warehouse, you are using Synapse dedicated pool and Synapse pipeline, and you can use T-SQL to do the data transformations, or also a Spark connector for Synapse dedicated pools to do the transformations. The process of this is copying the data using the Synapse pipeline or stored procedures, and then transforming the data in the dedicated pool, and then using Power BI import or direct query mode. Highlight of this is MPP, Massive Parallel Processing Engine. So it's a very fast data load and processing time for large scale data. You are using also T-SQL scripts. And you can also expand your skill set with Spark. The low lights for this is require data ingestion to the data warehouse, and it may be higher cost. The dedicated pool is a provision. You decide your compute from the beginning. You can pause the compute when you're not using it. The use case is enterprise BI, data science, and machine learning. And then recommendation is when you have the large data volume and data modeling requirements, and you also have been using cloud data warehouse and Synapse dedicated pool for other workload, then it might fit your need. The Lakehouse architecture, you are using Synapse pipeline or Apache Spark and serverless pool, and you can use a Spark skill set, different programming languages, Scala, Python, C#, SQL, or you can also use low code platforms such as Synapse pipeline or data flows. The process, you basically get the external tables created through the CDM util for bronze layer. You can use Spark or Synapse pipeline to transform to silver, and then transform to gold, and then use serverless to query the Power BI data either in import mode or in direct query. The highlight of this is open data format. You are using the Delta Lake format, and it also supports multiple programming languages with the Spark to do the transformation. Low light for this is new skill set for customers who have just T-SQL skill set. This is a new skill set to learn big data programming languages. Use case for this is enterprise BI, data science, and machine learning. And recommendation is again, for enterprise level data volume and data modeling. And if you're doing it with other systems, you have enterprise lakehouse architectures. You can definitely adapt to this model with export to data lake. Integration with existing data warehouse. So this one, you're integrating the data to SQL servers or Azure SQL Server or any third-party data warehouse. Then you'll probably dealing with the T-SQL scripts and other skills. The process is like you have to copy the data to SQL Server or existing data warehouse, build data transformations supported by the tool, and then use reporting tool of your choice. The highlight of this is backward compatibility solutions with existing solutions. So if you have on-prem data warehouse solutions and you want to continue using it for some time until you migrate all those workloads to the cloud, then this provides a backward solutions where you can ingest finance and operation data in the existing data warehouse to continue your solution. And then when times comes, you can move to any of the other platforms. From the low light perspective, you're doing this data ingestion that takes time and resources, as well as you're losing opportunity in some cases to move to the modern data tags when you're using on-prem SQLs. Use case of this is definitely the backward compatibility with existing reporting and BI solutions or integration solutions. And a recommendation is when you are working with the existing data warehouse solutions or integrations, this might be a short-term path for you.
These additional resources will help you learn more and get started with your own Export to Azure Data Lake implementation. Among these resources, I want to point out the Fast Track assets available on GitHub, as well as the Yammer group, where you can find a great deal of information and converse with others implementing the feature at this point in time. And finally, I do want to remind everyone that on the GitHub site with those Fast Track assets, we do have longer versions of the demonstrations that were conducted today, so you can see more detail on those full-length videos.
All right, I think we are done here. Rich, you want to share your slide, and I think we can go and answer some questions, highlighted questions from the Q&A.
There are quite a few questions. I think there are a handful of questions, of course, about the location of some of these resources and the best place to find additional information. So just to recap, many of the demonstrations that, yes.
Rich, do you want to maybe open the GitHub page and share that for some of the audience who are not aware of that? So all these architecture patterns and videos, detailed video of the demo and solution code is there already. So maybe we can also post the link here on the chat.
Yes, absolutely.
Okay, I'll take some of these questions which are unanswered right now. Could you add some size recommendations to comparing architecture patterns, logical data warehouse, approximately XGB or 1 GB, limit of Power BI Pro and things like that? So I think one thing here is there is no easy comparison, of logical data warehouse or Synapse dedicated pool and things like that. Because it's depend on the complexity. Even serverless can perform really well if you have large data set. It's meant for the large data set, but I think where it comes, some of the performance challenges what we are seeing is on the complex join and transformations. So if you require that, then probably the dedicated pool might make sense in that scenario. So yeah, so Rich is showing this GitHub link, and we'll share that link as well on the deck. Also, it's there, but this GitHub link, and if you go back a little bit up, Rich, the architecture patterns page is updated 4 hours ago. So it does have all the videos, detailed videos. So these video which we demoed, there are detailed videos as well as the solutions which we demoed are available here. Another question which is unanswered right now: what are the limitations on the number of exported table record counts? So number of table, there is a limit of 350 at the moment. It's a soft limit. If you require more than that, it's you can create support request to get it extended. Record count, there is no limit as such. Any other key questions, guys, before we wrap up?
Yes, JJ, there is one very good question, which is what technology is envisioned for Entity Store, or if we rephrase it, what is the roadmap for Entity Store?
Yeah, I saw that repeated question as well. Like Entity Store there is a plan to move that technology in the data lake as well. You're using export to data lake feature, and there is a GitHub solution at the moment. Like it's a kind of a try your own solutions where you can migrate some of the Entity Store and cook data in the lake using Spark or ADF. So it's available here on the GitHub page, but there is a plan from engineering as well to provide some data model or migrate some of these Entity Store to lake as well. There's no published roadmap on that, but it's there on the roadmap. It's there in the backlog and planned. Okay. We'll try to answer these questions as we go. I think we will stay to answer questions, but I think we're top of the hour. So Brad, you want to wrap up, or so that we can stay here and answer the questions?
That'd be great. Yes, to all of our attendees out there, if you have questions that you've submitted that are not answered, our presenter team's going to stay back for a few and continue answering those questions. So remain in the event and keep monitoring your questions for a response from our team here. I have posted a link to a short survey in the Q&A panel. We'd love to get your feedback on today's session and hear what you'd like to see in future events. So thank you for your participation on that. As a reminder, the recording of today's session will be available on the Tech Talks Community Dynamics page within 5 business days. And we'll conclude today's event by extending a big thank you to our presenters and audience for joining us today.